Part 7, differential operators. Lecture 5, the Nabla operator. Okay, this is Nabla operator. Now, in the non-conservative form. Now, let's write here from Gauss theorem. You can write. Now, this operator here, this is defined as limit delta V goes to 0, 1, del V, attention, integral on the boundary of delta V, this times the S. See? This over here you can see clear that is a vector, okay? Suppose we have a scalar here. So a scalar, this is a vector. Now delta V, let's write here. Delta V is just delta Ci, delta Cj, delta Ck. Okay? You see, this element here, I wrote dCi, but this is very small but finite element. Okay? Now, let's do as follows. Apply this integral on the boundary, this is the boundary, okay? Then I can express this operator is equal limit del V goes to 0, 1 del V. Now, this integral here, you see, there are 6 surfaces, okay? I use the Taylor series, okay, here. Taylor series. Exactly what we did on lecture 3, okay, on this part 7 here. So I can write, let's put over here, boundary of del V. So, using the Taylor series, I can just express, let's put over here, this integral over here, okay, the integral on the boundary, okay. Now I'll have partial respect to Ci, okay, of this. Now ds, you see here, ds over here is dash aj cross ak. Now right there, delta Cj, delta Ck. Okay, I'm substituting the differential, but the small finite in this case. Now I can write here aj cross ak. Okay. Let's write del Cj, del Ck. Don't forget that. That's a Taylor series. So there is here del Ci. Okay. Now, before we can represent this cross product by, in this case, I'll write over here. Okay. So this is equal partial on the boundary. Now, partial derivative respect to Ci. Then you see this can be a vector, can be a scalar, okay, can be a second order tensor, doesn't matter, because this is called operator, okay. Now I just repeat here, AI square root of G, okay, then del V. Why? You see, this over here, okay, is del V, quite easy. Now, you see, I'm just working on this part over here, okay? Then I'll substitute what I derive here, I substitute right here. Now, let us expand the integral. Let's expand this integral. You see, there are three variables, okay? This variable here, AI and square root of G. But you can do as follows. I'll put it here, this is equal, I will expand. So I can write here, integral on the boundary of AI see? I'll expand, okay? I can combine this one, okay, in this case. So this AI plus in this case, I will have this partial Ci AI square root of G. This is del V. You see, I expand, you see, attention now, this here, okay, I take the derivative of this, okay, in this case, okay, this is AI times this derivative, okay. Now, the product, okay, this is derivative of AI times this, okay, this is the product, derivative of this, okay, plus this times derivative of this. Now, we call that from part 5, lecture 7. You go there on part 5, lecture 7. All this term over here, I'll put a red. All this relation here is 0. Okay, you go there and see the derivation. Hence, this integral here will be integral on the boundary, delta V, will be AI partial I del V. Okay? Now, I will substitute this right over here. So, thus, the operator, this is equal, limit del V goes to 0, 1, sorry, that's right here. This is del V goes to 0, 1, del V. Okay. Now I'll substitute this over here. Okay. Integral on the boundary del V partial. Let's write AI first. Okay. Now AI, now derivative CI. Okay, that's quite easy. See, it's this over here. Don't forget, this is multiplied by del V. Then del V. Again, okay, I can cancel over here. So this operator, this is equal, in this case, okay, AI partial CI. You see, we call conservative form when we do not use this relation here. You just remain on the integral. Okay, that's called okay, conservative. Now, if you use, okay, this from part 5, lecture 7, so this is a particular case of this. Okay. Now, before, okay, years ago, okay,